Good morning, everyone. Today is Monday, April 19th, and we are going to be starting our new section in our class notebook called State Test Prep. Even though this is technically review for the state test that you guys will be taking in May, it is also just review in general for getting you prepared for 8th grade. So we're going to go to that new section, State Test Prep. And we're going to click on rational numbers. That's going to be our first page. Mine, of course, looks different because I'm making the teacher page. Our objective for today is to review the very first thing that we talked about at the beginning of this year, which was rational numbers. So we have some rational number rules to go over, and then we're going to practice using them to evaluate expressions, which are things that you guys have done before. Take a minute to pause this video and write or draw everything that you can remember about rational numbers. What are they? What can we do with them? And then go ahead and read that hint too. Awesome. Hopefully you paused your video there and you have a bunch of stuff written on your review section. But if not, let's think about some things that we can do with rational numbers. Okay. Rational numbers are kind of all of the numbers that we've been working with this year. We've got positives, we've got negatives, sometimes we have fractions or decimals, okay? All of those count as rational numbers, and there are rules for adding, subtracting, multiplying, and dividing them. So we're going to practice using those rules. And on this review section, if you wanted to have some things written down, we could kind of talk about what I just said. 2 could be a rational number, or a -3 could be a rational number. Give me some examples. And then for things that we are allowed to do with them, we can add, we can subtract, we can multiply, and we can divide. And the hint that we gave you was that the expression in the preview question is full of rational numbers. And we also know how to answer questions like this using our order of operations, which we're going to review today. So if you haven't tried this yet, go ahead and pause here and try to solve it first. But if you have already, I'm going to go ahead and do that now. The first thing we want to do is look for those parentheses. If there's an operation inside parentheses, we want to make sure we get rid of them. This only has one number inside that parentheses, so we don't necessarily have to do it now, but we could use our leave, change rule. So just change that into a +2. Okay, anytime you have your subtraction symbol next to a negative, that is the same thing as adding a positive. So we could go ahead and change that, and we don't have any parentheses to worry about at all. The next letter in our PEMDAS is exponents. There's no exponents, so we skip that one as well. And then we have multiplication, and we can multiply 2 times 4. So my -10 is going to stay the same. My 2 times 4 is going to become an 8 with my plus sign from there. And then I'm still adding 9. After multiplication, we normally would have division, but there are no division symbols in here, right? There's nothing that's telling me we're doing division. And then we have addition and subtraction, but we also don't have any subtraction. All of these are adding rational numbers, even though the 10 is negative. So let's go ahead and think about that. I'm just going to give myself one more line of space here. And we want to add from left to right. We want to go in order, just like we were reading a book. Every time we read a book or read a sentence, we go from left to right. So -10 plus 8. That would give me a -2. And then I still would have to add that 9 on, but I can bring it down to the next step. And now I'm going from left to right again. -2 plus 9. That should give me a positive 7 for my final answer. So as we can see, we used a bunch of our rules in there. We used our leave, change rule. And we use our order of operations. We could have used our commutative property if we wanted to add these differently. We would still get the same answer. And those are the things that we're going to review today. Before we start talking about some rules, I want you guys to go through these sections: addition, subtraction, multiplication, and division. Don't worry about the rules column yet. But on our kind of practice column here, start filling in some of those answers. Pause here and see how many you can get. All right. Hopefully you paused and solved some of those. You can use a calculator on these, although you may not need to. So let's go through and figure some of these out. 5 plus 7 should give me 12. Negative 4 plus 12 should give me a positive 8. Negative 9 plus a negative 3 should give me a negative 12. In my subtraction section, I have 7 minus 10, which should give me 3. Sorry, negative 3. 4 minus negative 8, which should actually give me a positive 12. Negative 5 minus negative 2, which should actually give me a negative 3. If any of these are tricky so far, just hold on a sec. We're going to talk about our rules, which might make some of these things a little bit more clear. Multiplication section, we have 5 times 2, which should give me a 10. We have negative 3 times 6, which should give me a negative 18. And negative 8 times negative 9, which should give me a positive 72. I'm just going to fix this 10 here because that kind of looks like a 6. And last but not least, we have our division section. 36 divided by 6 is 6. Negative 63 divided by negative 9 should give me a positive 7. And 110 divided by a negative 10 should give me a negative 11. All right. Pause your video here if you didn't have all of these down, and make sure you write them down. These answers are going to help us determine some of our rules that we are reviewing today. Awesome. So let's go ahead and look at that addition. What are some addition rules that you guys can remember from the very beginning of this year? Think about why we got these answers. When I add 2 positive numbers together, my answer should be getting bigger, right? More positive. If I add 2 negative numbers together, my answer should also get bigger, more negative. But what happens in B here? I'm adding 1 negative number and 1 positive number. And my answer actually got smaller than one of the values that I had started with. Right? That's because we are thinking about the addition rules that we had. So here we go. I'm going to write some of them down. When we are adding two numbers with the same sign here. Actually, let me go back and show you guys where we are getting these rules from. We did these in Unit 2, and we had a bunch of different pages, but page 3 was our rules for addition. And so we had already figured out some of these rules. Adding for numbers with the same sign, you add the absolute value of the numbers. then use the common sign. But for adding numbers with different signs, we actually are subtracting the absolute value of the numbers and then using the sign, okay? So let's show that back on our page for today. Okay, I'm gonna try to explain that a little bit more as I go as well. So let me get a text box and start typing here. And then we're gonna move these over where we need to put them. So we have 2 addition rules. Maybe I will insert, or on my homepage here, I'll make some bullet points. Awesome. Adding the same sign. That has one rule, and it is that we add the absolute value of the numbers and then use the sign that we originally had in common. All right, I know my page is getting a little crazy here. Let me put these over where they belong. Okay. And so that is for when we were adding with, oops, I realized I'm on the wrong page here. That's for when we were adding with both positives or both negatives. So we can see 5 plus 7, we're adding the absolute value, which just means the number. Don't worry about the signs yet, you're just taking those numbers, 5 plus 7. And then we were using the sign that we started with. They were both positive, so my answer has to be positive. Okay. The same thing happens when we have numbers that still have the same sign, but now they're both negative. Okay. You add the absolute value, which means only the number itself. 9 plus 3 gives me 12. Then you're using the sign that they had in common. They both started as negative, so my answer has to be negative. The only ones that are different when you're adding with 2 different signs. Okay. And that means you're actually going to subtract the absolute value of the numbers and then use the sign of the bigger original number. And I'll explain what that means as well. Okay. That was for questions like B here. We have 1 negative and 1 positive. It doesn't matter what order they're in, but they have 2 different signs. That's the reason why I'm using this separate rule. And it tells me to subtract the absolute value. So again, I'm just looking at the numbers. We have a 4 and a 12. When I subtract those, we get 8. And then we're using the sign of that bigger number, the bigger original. So looking back at the 2 that we started with, 12 was bigger and 12 was positive, so my answer has to be positive. If the negative number was bigger to start with, then my answer would have to be negative to end with. Okay, we're looking at the bigger number there. So those are our 2 addition rules. And now we have some subtraction rules, okay? Because as we can see, adding and subtracting, we think about them as opposites, but they're really, really similar. And we can actually change subtraction into addition, just like we changed that addition into subtraction when we had 2 different signs. Let's take a look at this one now. I'm going to pull a text box over just so I can write. I'm going to put in my bullet points here. Subtraction is the same as addition when we use our leave, change rule. Okay. That means you're leaving the first number alone. Changing the operation from the middle. And then also changing the sign of the second number. That is the biggest subtraction rule that I have for you guys today. So let's see how that's working. We have a 7 here. We leave it as a 7. But we can change that subtraction sign to a positive. Okay, so I would have 7 plus, and then my positive 10 would be changing to a negative 10. And now that we have this written as addition, we could go back up to this addition rules. They're two different signs. So we're taking the numbers themselves and subtracting. Okay, we have a 7 and a 10. That means there are 3 numbers in between them. And then you're looking at the bigger number to tell you whether it is positive or negative. With questions like B, it's a little bit easier to see because we have those two negative symbols next to each other. One is our operation saying subtraction, and one is the negative from the 8. It's a little bit easier to see how you would be changing those. Okay, we would leave the first number alone. That's our first leave part here. We would change the subtraction to addition. And we would change the negative 8 into a positive 8. Okay, and that's how we got our answer. That equals 12. Same thing for C as well. We would leave the negative 5 alone, change our subtraction to addition, and change our negative to a positive. So this one would look like negative 5 plus positive 2. And again, we go back up to those addition rules and use the rule about two different signs. So looking at the numbers, you would have a 5 and a 2. You would actually subtract those. And then looking at the signs, 5 was the biggest, so we would have to put on that negative in our answer. Okay, that is our leave, change rule. That's our biggest subtraction rule. Obviously, there are ways that you can subtract without changing it to addition, if that's easier for you. But just in case you like adding better, it is possible to change those. Awesome. Let's move down to some multiplication and division rules. These ones are a little bit easier to understand and remember from the beginning of the year. We only have 2 of them. Actually 3 of them, sorry. We have 3 of them for multiplication, and they're actually the same for division. There's 3 more rules that we're going to have that are the same for both of these 2 sections. So here we go. Let me make my text box. Uh-oh, it disappeared on me. You have to write a random word to actually create that, then bring it over and then put that word away. There we go. We have a couple of rules for multiplication that depend on the positives and the negatives. Okay, 2 positives makes positive. Okay, so I'm going to say positive times, my little star symbol will be my times symbol because I can't make that multiplication dot. Positive times positive. I'm not sure if I'm caps here. Equals a positive. Then we have a negative times a positive, okay? And we can see that one will always equal a negative. And it doesn't matter if these are switched, Okay, as long as there's one negative and one positive, the answer also has to be negative. Okay, even if the 6 was before the 3, we would still be using the same rule. One would still be positive and one would still be negative. And our very last rule is negative times negative, which equals a positive. Two negatives make positive. And I'm going to go ahead and actually copy this whole box because they are the same rules for division. Oh, not sure why they wrote them there. Click a new box here and copy those, bring them over. Okay. A positive divided by, let me change this symbol. I'm going to use my slash symbol. Another positive equals a positive. We can see that. A negative divided by another negative equals a positive. We see that with question B. And then when I go down here, there's one positive and one negative. So that would be this rule here. There's one of each. I'm dividing again. And we see that we still get a negative answer. So those are our 3 rules that actually work for both multiplication and division. Because dividing by a number is the same as multiplying by its inverse. So just like we think of adding and subtracting as opposites, but they're really actually very similar, multiplication and division do the same thing. We think of them as opposites. They are very, very similar. They have the same exact rules. Awesome. Let's put all these things together. We talked a little bit about PEMDAS when we were doing the DIN, our order of operations acronym. So I'm going to fill that in here, PEMDAS. And then I want you guys to pause your video here and fill in what those words mean. All right, hopefully you filled them in. Here we go. Oops, I almost started writing PEMDAS again. P is for parentheses. I always spell that wrong, so let's see what's going to happen. So spell it correctly for me. E is for exponents. M is for multiplication. D is for division. A for addition, and S for subtraction. I'm not sure why I did some of them capital and some not, so let me fix that. It doesn't matter. There we go. And just like we did for our DIN, we can use these in order to solve any of these types of questions. Do I have any parentheses in this problem? I do, but there's not really a lot of stuff to do inside of there. That's just one number. So technically I could leave that until the end, or I could do what I did in the DIN and use my leave, change rule at the very beginning to just get rid of those. Because I already showed you the first version of how to do that, getting rid of them to start, this time I think I'm going to leave those because it's only one number, so it's not really a parentheses we have to worry about. And we're going to see what happens if I leave it till the end. E for exponents, we don't have that, but we do have M for multiplication. So if I'm leaving everything except for my multiplication, the 5 stays the same, that negative would stay the same, and my negative 6 times 8 is the only thing that I'm solving right now. Negative 6 times 8. And that should give me a negative 48. Okay. And like I said, I can put parentheses on this if I want to, just to separate out those two symbols, but I don't really have to. These parentheses wouldn't mean much, which is why we didn't have to worry about them originally. And I still have my +2. My multiplication is complete. Division, we don't have it. Addition, we do have, okay? And here's where we could make some changes as well. Now you could use that leave, change rule to make this into addition first, Or you can still leave it until last and think about it as subtraction, okay? They both kind of go at the same time. And so it wouldn't really matter a whole lot. I'm going to go ahead and change this to addition now because I don't like seeing that double negative. And so now when I do that, either in my head or in my calculator, doesn't matter what I add up because we're all going to get the same answer. So you can read from left to right, or you could kind of switch things up, and we're going to figure out why we're allowed to do that in our next two properties in a second. But for now, let's go from left to right. 5 plus 48 should give me a 53. And then I'm adding 12, and we should get a 65. Okay, I read it from left to right. Wouldn't really matter if we did that because of some properties we're going to talk about now. Who remembers our two properties from the very beginning of this year? We use order of operations with examples like the one we did because we had multiple operations in the same expression. We had division, or sorry, we had multiplication mixed in there. We had some parentheses that we're a little bit unsure of, addition and subtraction. But what would happen if we only had multiplication or we only had addition? There are two properties that we can use. For example, on question A, if I did not want to multiply this negative until the very end, I could change this to say 5 times 3 times negative 2. Okay, that is using my commutative property. I'm changing the order. Okay. We are allowed to change the order if we are only multiplying or only adding. So this example, we were only multiplying. We were allowed to switch it up. Now I could solve it from left to right. 5 times 3 is 15. Then I still have that times negative 2, which would make a negative 30. Okay. I also could have put some parentheses on this to make it very clear that I multiplied those first. That would be my associative property. Okay. Using parentheses to choose which part you are adding or multiplying first. I'm actually going to put which part you are solving first. Okay. If you are only multiplying or only adding in an expression. Okay, again, this only works with multiplying and adding. We cannot use these properties with subtracting or dividing unless you change them to adding and multiplying first. And I'll make that clear in a second. So we just use both on this multiplication problem. Let's use both now on this addition problem. Maybe I want to add this 6 and negative 7 first. So I'm going to change this to say 6 plus negative 7 plus 4. Okay, that's my commutative property. I'm only changing the order. And maybe 6 plus negative 7 is a little bit easier because we can automatically see we would have one negative left. we add those. Plus 4, which would actually give me 3, which would be positive. Okay, that's my commutative property. I'm only going to use that one on this example. And now let's go down to C. Let's practice our associative property again. But remember, we can only do this with adding or multiplying. So we actually have to use our leave, change rule first. See this negative here? My 10 would be left the same. Then I would be changing this operation. Right now it says subtract, but I'm changing it to addition. And right now this 6 is positive. I'm changing it to a negative. Okay, leave, change. Change the operation and you change the sign. This is already addition, so my plus 8 is already finished. We don't have to use leave, change on that one as well. Now that we have only addition, we can go ahead and use that associative property. I can say that this expression is still the same as this expression. Negative 10 plus negative 6 in parentheses. Okay, I didn't switch the order of the numbers. I only added some parentheses on there. And that's telling me to solve that first. Negative 10 plus a negative 6 actually gives me a negative 16. We use those addition rules. And then I'm adding my 8. And that's actually going to leave me with a negative 8. Again, I'm using my addition rules that we talked about above. The more we practice them, the easier they get. You won't even have to think about those addition rules or multiplication or division or subtraction rules at all because we've been practicing them all year. And we can also use our calculator to help us out a lot. So this is everything that we reviewed for rational numbers. Okay, we just put all of Unit 2. Remember I showed you that Unit 2 with all of our pages? We put all of that stuff into one page. Now we have one rational numbers page with all of the rules we've learned, and we're going to complete some practice. So this practice is exactly the same as the example that I showed you up here and the example that I showed you in the DIN question. All we need to do is make sure we're following PEMDAS, parentheses first, then exponents, then multiplication and division, and then addition and subtraction. And we can use our calculators as well to put these right into the calculator and solve them that way too. So practice those for the rest of our time today. Our exit ticket is to create your own expression and evaluate it using PEMDAS. So see if you can make an expression that's even more challenging than the ones we gave you here and try and solve those. We have our self-reflection, of course, and then we are completing standard quizzes on Canvas. There's an NS standard quiz. Once you click on it, it brings you to all of the NS data wall quizzes, and you're completing at least one. That's it for today, guys.